Welcome, my people, back to another video lesson. This week it is on 5.7 roots and zeros. So to be successful on these video lessons, my advice is to have a notebook handy so you can take notes on what you need to take notes on. Please feel free to pause, rewind, fast forward to make this go at your pace so it can be as great as it needs to be for you. Okay, so here we go. We're going to jump right in. So basically 5.7, if you've paid attention in class, we just finished section 5.6. In 5.6 we factored polynomial functions completely, and then we found all the zeros to those functions. Well, today those directions are going to be very similar. The only thing that's different is you will not be given a factor. You have to find one on your own. Okay, so if you read the directions, we're asked to, number one, factor completely. Let me get my pen. We're asked to factor completely. That's number one. And the second thing we're asked to do is to find all the zeros. So two things that we're asked to do on this one problem. Okay? All right, so the very first thing that you're going to look at here is you are going to pull out your graphing calculator and you are going to graph this function. So as I pull my calculator out over here, I'm going to go and graph, so 2x to the third minus 15x squared. Shoot, I messed it up. So we have 2x to the third minus 15x squared plus 34x. Hopefully you have entered your equation significantly faster than I did. Minus 21. Okay. And then what I'm going to do is I'm going to go to Zoom 6. Okay. Zoom 6 puts your graph back in the standard viewing window. Okay. And then what you're going to see is you're going to see a pretty good picture of this graph. Okay. Now here's what we're looking for. We are looking for a set, one or more zeros that we feel like we can actually use that help us find, let me make the screen just a little bit bigger. Here it is. All right. So what we're doing is we want to see, we look at the graph clearly and see there are three zeros. If you have to zoom in a little bit on this little part, you'll see that it dips below the x-axis and comes back up. So it intersects the x-axis at three different places. So what we need to do is we need to try to find the coordinates of those three x-intercepts if we can. Now what I usually do is the first place that I check is I check the table. Okay, so I go to the table, and what I want to look for is I want to look for any x value that makes y equals 0. Okay, and I see two of them. I see one of them happens at x equals 1 and one of them happens at x equals 3. Now what the biggest mistake that some people make is we're not looking for where x is 0, we're looking for where y is 0. And like I said, we know there's going to be three answers because we looked at that graph, and then we also know that the degree is a third degree, so we're trying to find three x values. And just by looking at the table alone, we can see that there's 1, 2 x values that work. So if I go back to my graph, okay, just based on the table, it looks like x equals 1 is my first and x equals 3 is another. So it looks like I'm going to need to try to find the coordinates of this point right here. Now the calculator could actually do that work for you. Okay, so the calculator does the work, but I'm going to show you how to use synthetic division to get that as well. So let me minimize this stuff and get rid of that for just a minute. Okay, so here's what we learned from our graph. We learned that we have two zeros, x equals 1 and we have x equals 3 as two of our zeros. We know that there's still one more that we're trying to find. Okay, but what we're going to do is we're going to take those two x values and we're going to do synthetic division twice using the original function. Now it doesn't matter if you start with the 1 or if you start with the 3, okay, but we're going to take the coefficients, okay, and do our synthetic division. Bring down the 2. 2 times 1 is 2. negative 13. Positive 21 times 1 is positive 21. Remainder 0. We should not be surprised by that. Okay. So then what I'm going to do is I'm going to turn right back around and I'm going to do synthetic division again, but this time I'm going to use the other 0. So if you started with a 3 here, you're going to do a 1 down here. Okay. So we do our synthetic division, bring down the 2. 2 times 3 is 6. Negative 7. Negative 21. Remainder 0, which is what we expected. Okay. So now here is what we've essentially done. We've taken that function f, and the very first thing we did is we factored out the 0 x equals 1. Well, you have to think, if the 0 is x equals 1, how does that translate to a factor? So what factor, another way to ask that question is, what factor would have produced x equals 1 as its 0? And that is x minus 1 as a factor. Similarly, we know that x minus 3 is also a factor. So we just took function f and divided out x minus 1, and we also divided out x minus 3, and what we have left over is our quotient right here, which is 2x minus 7. So there, you circle that, and that is this polynomial function that is factored completely. So that's your answer to part 1. Now to find the answer to part 2, we actually have 2/3 of the answer already done from the calculator. So looking at our table, we saw that x equals 1. We also saw that x equals 3. And now we're finally ready to find that third missing exponent by taking this 0 here, this factor, and setting that equal to 0. And we end up getting x equals 7/2. Circle that, and that is your final answer. So very similar to what we did in 5-6. Again, the only difference is you go to the graphing calculator to try to find zeros before you do anything else. Okay. All right, so let's move on to another problem. So here's same directions, factor completely, and find all the zeros, and leave your answer in simplified radical form. This part foreshadowing, this part's going to be important in the directions. Okay. So number 2, obviously what you're going to do is you're going to go and you're going to graph this on your graphing calculator. Okay, so pull up your calculator, and while I'm updating it here, you go ahead and do the same thing. So it was 6x to the 3rd plus 20x squared minus 19x. And please be really careful when you enter these, because it's always so frustrating when you just type one thing wrong and your graph doesn't work or doesn't look right, because if you type one number wrong, you're going to get all the zeros wrong. Okay. Alright, so just looking at the graph, the first thing I see is, again, because the degree of f is 3, I'm looking for a total of 3 zeros, and I see on the graph, I see 3 zeros. Okay. So next thing I'm going to go to is I'm going to go to my table, and I'm going to look to see if on the table I can find anywhere where y is 0. Okay, so I know one of the zeros is between -4 and -5. Cozad, how do you know that? Well, here's how I know. I look at the y values, and notice how when x is -4, y is 14. Well, when I go to x equals -5, y becomes -153. So we go from positive to negative. Anytime you have a sign change like that, that means somewhere between these two x values you had to cross the x-axis. So I know that one of the zeros is going to be between -4 and 5, okay, but that doesn't really help me because that's not a number that I know. So then I'm going to keep scrolling and try to find another sign change in the y values. Okay, I'm getting extra large. Okay, so I don't actually in the table see another sign change. Okay, so what we're going to have to do next is we're going to have to try our next tool. Okay, so go back to your graph, and we're going to go to Second, Calculate. Now this is a menu screen that we've seen before in Chapter 5 when we actually used it to calculate relative minimums and maximums. But here we're going to use option number 2, which is to find a 0. So what this tool actually allows you to do is it allows you to calculate the coordinates of these points. So I'm going to start from left to right. I'm going to start by finding this 0 over here on the left. Okay, so I'm going to move my cursor over to where, I lost it. Okay, this is going to be something that happens to you sometimes as well. You're going to lose your cursor. But luckily, the X and Y coordinates of your cursor are given down here. So right now, of course, I can't see the flashing cursor because it's at y equals 71. Okay, so I'm going to keep going, and here it starts to come down. Okay, again, I'm trying to, there it is. Okay, so there's my flashing cursor. But clearly, if I stop there, that's not to the left of this 0. So go one more. Okay, doesn't matter that you can't see it. You're clearly to the left. Press enter. Now move your cursor back to the right of that 0, anywhere you want that's on the right. Press enter. Press enter a third time, and it spits out for us negative 4.12132. Okay, that's great, but if we want our answers, like I said, in simplified radical form, that's not a decimal that I know how to convert to a fraction. So I need to keep looking. So now let's move on to the next 0 over here. The next one. So I'm going to go back to second calc, option 2, and we're going to move our cursor over here close to that next 0. Here it comes back down. There it is. Okay, so that's a pretty good spot to stop it. Okay, it's not precise. It doesn't have to be perfect, just so long as it's to the left of that 0. And then I press enter. Okay, so now I want to go down to where I'm to the left of that 0. And again, think about your sign change in y. Okay, left of 0 here is positive y's. To the right of zeros are negative y's. So I press enter again, and a third time, and it spits out, ooh, another ugly decimal. So that doesn't really help us either. Our last hope is this last 0 here. So again, go back to second calc, option 2, and you're going to move your cursor just a few spaces so that it's to the left of this 0 right here. Press enter. Move it a few more spaces over to the right so that it's clearly to the right of that 0. Press enter. Guess. Voila, we see a decimal that we should be able to convert to a fraction. Okay, 0.666666667 is 0.6 repeating. You only see the 7 because the calculator runs out of room. Okay, so here's what we're going to do. We're going to go back to our notes here. Okay, and we are going to write ourselves a note that we found that x equals 2/3 is going to be one of the three zeros. So that means in this case there are 2 zeros that I need to find. Okay, so here's what we're going to do. We're going to do synthetic division using that 0 of 2/3. So I've got 2/3, and then I use my coefficients 6, 20, negative 19, and 2. So we do the synthetic division, and we bring down a 6. 6 times 2/3 is 4. 4 plus 24, or 20, is 24. 24 times 2/3 is 16. 16 plus negative 19 is negative 3. And then negative 3 times 2/3 is negative 2. We should not be surprised that we get remainder 0. Okay, so now let's take a look at where we're at. So we've taken function f, and we factored out x minus 2/3. X minus 2/3 is the factor that matches with the 0 that we found. Okay, so then the quotient that I have left over after I took x minus 2/3 out is I had 6x squared plus 24x minus 3. I got those from the coefficients after synthetic division. Now the next thing that I'm going to want to try is I'm going to want to try to factor this trinomial. Okay, so the GCF in that trinomial is 3. So I'm going to start by bringing out a 3, and I'm going to slide that all the way out to the front. So I have 3 times x minus 3/2 times 2x squared plus 8x minus 1. And you can try any way that you want to factor that trinomial, and it's simply not going to factor. Okay, so once you realize that trinomial can't factor, you're done with part 1. We have factored that completely. Now part 2, we have 1/3 of the work already done in part 2, because we know that one of the x values is 2/3. And then to find the other 2 x values, we're going to do quadratic formula. So I would pause the video now and try to do this quadratic formula yourself here on this trinomial, and leave it in simplified radical form. So pause it now, try that yourself, and then come back and see if you got it right. Okay, welcome back. Hopefully you actually paused it and did the work. So let me show you what I got. Okay, so we would do -8 plus or minus the square root of 64 minus 4 times 2 times -1. So that ends up being 72 all over 2 times a, so that's 4 in this case. We are all stars of mathematics in here, so we don't leave radicals that aren't simplified. So you can do a little bit of work on that and see that 72 is 36 times 2. The 36 comes out as a 6, so I have 6 root 2 left over, all over 4. And again, we are true all-stars, so we don't even stop there. We're going to divide a 2 out of the -8, the 6, and the 4 to get -4 plus or minus 3 root 2 all over 4. And that, ladies and gentlemen, are your 3 zeros for this function. Okay? Now, before I move on, this homework is going to be really important that you use. This is going to be really important that you use. If you heard that, I just tripped in the classroom alone. That's embarrassing. I'm glad you aren't here to see it. But this homework is going to require a lot of graphing calculator work, and I know not all of you have a graphing calculator, so I want to actually show you a resource that is awesome to use. Okay, it's called Desmos.com, and if you haven't checked it out before, I'm going to show you on here how it works. Okay, so you can actually do this on a laptop, or it actually works on your phone's web browser as well. It's really convenient, and it's a really powerful graphing tool. So I already forgot what my function was. So let's do 6x to the third plus 20x squared minus 19x plus 2. And as you type, you see that it builds the equation for you over here. And here's what I absolutely love about it. Okay, you can simply click on these points and it will show you the coordinates. Okay, and if you look at those coordinates, you can see that's not a decimal I know how to deal with. That's not a decimal I know how to deal with. 0.667 certainly looks like a decimal that is convenient to work with. Okay, so Desmos is an awesome tool. It's a lot faster actually than using your graphing calculator. Unfortunately, I can't let you use Desmos on your quiz or your test, but this is a resource that I would highly recommend you using. Okay, well, we're just about done. There's just one more type of question that I need to show you, and we'll do a few examples of that type of question. Okay, but again, please note that when you're trying to factor completely and you're not given one of the factors, you go to the graphing calculator and find as many zeros as you can use and go from there. Okay, so this is the next type of question that you'll be asked to do. Write a polynomial function of least degree with integral coefficients. Integral coefficients just means all of your coefficients should be integers, no fractions. Okay? All right, so basically what this problem says is it says, okay, suppose you have a function where it has a 0 at x equals -5, it has a 0 at x equals -1, and it has a 0 at x equals 2. Okay? So here's the deal. So we're basically going to work backwards. So think to yourself, what factor would produce for you a 0 of x equals -5? It's okay to answer out loud, even if you're sitting by yourself at your house. So go ahead, say it. Very good. The factor is x plus 5. Excellent. Okay. You can also, I know, this is so weird. Okay. But so the factor that matches with x equals -1, or that would produce x equals -1, that factor would be x plus 1. And then the last factor would be x minus 2. Okay. So then this problem simply turns into a multiplication problem where you apply the distributive property. So let's call this f of x. Now when I do this, I'm going to multiply 2 at a time. So I'm going to do the first 2. And I get x squared plus 5x plus 1x is plus 6x plus 5 times x minus 2. So now that I have a trinomial times a binomial, there's a lot of ways that you can do that. So there are your, I should have six terms, 1, 2, 3, 4, 5, 6. Now combine your like terms and we get x cubed plus 4x squared. That would be minus 7x minus 10, and that is your final answer. Notice we have no fractions, only whole numbers. So pretty simple. Now they won't always be that simple, so I'll show you two more that are a little bit more complicated. Okay, same directions but different types of zeros. Now I need to talk to you about 3i. That's a complex solution, and there's something called the complex zero theorem that basically tells you that you will never have the positive 3i without the negative 3i. So even though it just tells you that 3i is a 0, you have to be smart enough to know that you're never just going to have the positive without the negative also. So when I write that out, I include the plus or minus there. Okay? I also have x equals 2. There's nothing special that I need there. And there's an irrational root theorem that also says that you'll never have just a positive or a negative square root. You'll have both. So even though the plus or minus is not shown, you know that it has to be there. So at first glance, you may have thought that this only had 3 solutions, but it actually has 5. 1, 2, 3, 4, 5. So now we're just like where we were in the last problem. We're going to work backwards to get these factors that produced these zeros. So for plus or minus 3i, you have to think to yourself, what would that radical have been before it was 3i? And you're right if you said negative 9. So x equals plus or minus negative 9. And then if we wanted to get rid of the square root, we would just square both sides. So we would have x squared equals negative 9. And you're probably already ahead of me. All we do next is add 9 to both sides, and we get x squared plus 9 equals 0. So that is one of the factors. X equals 2, that factor is easy. We would just get x minus 2 equals 0. And x equals plus or minus the square root of 3. If we square both sides, we get x squared equals 3. Subtract the 3 on both sides, and we get x squared minus 3 equals 0. So now what I'm going to do is I'm going to rewrite this function in factored form with my 3 factors. X squared plus 9 times x minus 2 times x squared minus 3. Now this multiplication is significantly more spicy. Okay, so we have 3 parts that are being multiplied by each other. Okay, so I'll do the first 2. So we get x cubed minus 2x squared plus 9x minus 18. No like terms to combine there. So this next one's going to be spicy. So I have a 4 term times a 2 term, so that's going to give me a total of 8 terms if I multiply correctly. So x cubed times x squared is x to the 5th. You should be doing this while I am too, because you know how to do this. Okay, you can handle this. Minus 3x cubed minus 2x to the 4th plus 6x squared plus 9x cubed minus 27x minus 18x squared plus 18 times 3 is 30 plus 24 is 54. Alright, now all I need to do is combine my like terms. So I have x to the 5th. I use that. I only have one x to the 4th term, so minus 2x to the 4th. I've got minus 3 plus 9 x to the 3rd, so that's going to be plus 6x to the 3rd. I have a 6x squared minus 18x squared, so that's going to be minus 12x squared. Minus 27x plus 54. Again, I don't see any fractions. I'm good to go. There is my function. Okay, so let's just look at one more using the same kind of concept, and then we'll actually be done. Okay, so the last problem, number 5, is very similar. Okay, we're going to work backwards from our zeros. So we have x equals 3 over 2. We have x equals 4 plus 2i. And we have x equals 1 plus the square root of 7. Now remember, the complex root theorem tells us you're never going to have the positive without the negative also. And the irrational root theorem tells you you're never going to have the positive without the negative also. Okay? So then what we're going to do is we're going to work backwards from each one of these zeros to find the factor that produced it. Okay? Now, you could, on this first one, just subtract 3/2 on both sides, but remember that we want integral coefficients. We don't want any fractions. So what I'm actually going to do is I'm going to call this 2x equals 3, and then 2x minus 3 equals 0. That's going to help me to avoid having fractions. Now this middle one, you got to pay extra close attention here. The first thing you're going to do is move the 4 to the other side. So you get x minus 4 equals plus or minus the square root of negative 4. So I did two things there. I moved this 4 here to the other side, and I rewrote 2I as the square root of negative 4. So then I'm going to square both sides. X minus 4 quantity squared equals negative 4. I FOIL this side. X squared minus 8x plus 16 equals negative 4. Add 4 on both sides, so you get x squared minus 8x plus 20 equals 0. So there's your second factor. Third factor, same concept. Subtract 1 on both sides. Square both sides. X minus 1 squared equals 7. FOIL the left. X squared minus 2x plus 1. Subtract the 7 on both sides. X squared minus 2x minus 6 equals 0. So then what you have is you put it all back together in factored form, and we have 2x minus 3 times x squared minus 8x plus 20 times x squared minus 2x minus 6. Now that multiplication is about as spicy as it comes. Okay, so I'm going to actually leave you there for the sake of time. Just have you multiply that out yourself. So that, in a nutshell, is everything you need to know on 5.7. So right now you're going to work on a in-class assignment to practice this a little bit more. So thank you so much for paying attention. I hope this was helpful. Again, I miss you, and I'll see you when I get back.